Hey everyone, and welcome. For decades, we've all had this dream of flying cars zipping between buildings, straight out of a movie. Well, today, that dream has a new name, Advanced Air Mobility, or AAM. And we're going to dive into all of it. The massive hype, the really tough engineering, and the real-world timeline to see if this is finally about to happen.
So let's just get right to the big question, right? Is this just another false start, another promise that never pans out? Or are we genuinely on the brink of a transportation revolution? That's what we're here to figure out, separating the incredible promises from the huge challenges that are still ahead.
All right, first up, let's talk about the vision. Because before we get into the nuts and bolts and the engineering, you've got to understand the incredible future that the AM industry is selling us on.
And this quote from a big industry expo, it just captures the excitement perfectly, doesn't it? The language they're using, it isn't just optimistic, it's revolutionary. They see this as the fundamental next step in how we all live and move.
And the vision here, it's huge. We're talking about everything from completely skipping your morning traffic jam to getting packages delivered in a fraction of the time, all the way to delivering life-saving medical supplies in minutes instead of hours. The goal is nothing less than creating a whole new layer of transportation, one that's cleaner and faster right above our cities.
Okay, so that's the dream. It sounds amazing. But to make that dream a reality, you need the machine. So let's move on and talk about the aircraft itself.
So while we all love to call them flying cars, the real industry term you're going to hear over and over is eVTOL. Just think of it like a hybrid. It takes off and lands straight up and down like a helicopter, which is perfect for tight city spaces, but then it flies forward like a plane, which is way quieter and a lot more efficient. And the best part? It's all electric.
And right here, this is where all that hype smacks right into the hard reality of physics and engineering. Because look, the concept is brilliant. But actually making thousands of these things fly safely and affordably over our heads, that means we have to solve some absolutely massive technical hurdles first.
The single biggest challenge? It all comes down to power. Lifting a vehicle plus its passengers straight up into the air takes a ton of energy. And right now, the batteries are the main bottleneck. They have to be incredibly powerful, but at the same time, they have to be incredibly light. That's a tough balancing act.
Let's actually put a number on that so you can see the gap. To get a useful flight range with a decent number of passengers, engineers say we need batteries with an energy density of about 400 watt-hours per kilogram. To put that in perspective, the best batteries we have today top out around 300. Closing that gap is one of the biggest jobs for researchers right now.
And believe me, it does not stop with the batteries. The electric motors have to be absolute powerhouses for that vertical lift, but they also have to be quiet enough that they don't drive an entire city crazy. And then there's navigation. These eVTOLs have to fly safely through complex city canyons where GPS signals can get blocked, all while avoiding each other. That's a huge challenge.
Okay, let's just imagine for a second that the engineers are geniuses. They solve all of that. We have the perfect eVTOL ready to go. A massive question still remains, where on Earth is it going to land? And this brings us to the next major piece of the puzzle. See, it's not enough to just build the vehicle. You have to build its entire world from the ground up. You can't just land these things on any old street corner or rooftop.
The answer is a totally new piece of city infrastructure called a vertiport. Just think of them as mini airports for eVTOLs, placed on top of buildings or at major transport hubs, and they've got everything: high-speed chargers, passenger waiting areas, the whole shebang.
But it is so much more than just the landing pads. We're going to need a whole new air traffic control system for low-altitude flights, a massive charging grid to keep all these vehicles powered up, and maintenance centers to service them. It's an entirely new layer of infrastructure that has to be woven into the fabric of our already crowded cities.
Now, this problem of developing a revolutionary new vehicle and all the infrastructure for it at the exact same time, it might sound almost impossible, right? But here's the thing. We've actually seen this movie before.
In fact, we can learn a ton by looking at the recent rise of electric cars. Analysts at Deloitte point this out, and it's a great comparison. The EV industry faced remarkably similar challenges just a decade ago, and it gives us a really powerful roadmap for what the AM world is facing now.
Just look at this table. The parallels are striking. Remember how early EVs needed partnerships to build out a charging network? Well, AM needs partnerships to build vertiports. Remember how EVs had to figure out how to scale battery factories and get all the raw materials?
AM has to scale aircraft production. And just like EVs needed massive investment to build factories, AM needs that same kind of cash for manufacturing and for the incredibly expensive aircraft certification process. It's the same playbook.
So with all of that in mind, the incredible potential, the huge hurdles, and the lessons from the past, what's the bottom line? When can we actually expect to grab our phone and book one of these things?
Well, the first thing to know is that this won't be a sudden flood of air taxis everywhere. The first services are going to be very specific. Think about fixed routes, like an airport shuttle that flies you from your terminal to a vertiport downtown, letting you soar right over all that traffic. We'll also probably see cargo and emergency medical deliveries take off before widespread passenger travel, because those are just easier places to start.
And here is the timeline that the industry and regulators are actually working towards. Right now, prototypes are flying and getting certified. By around 2025, we should see the very first operations begin, probably with things like cargo delivery. But the really big date to circle on your calendar is 2028. That's the target for the FAA's Innovate 28 program, which is aiming to have real, scalable air taxi services up and running in several U.S. cities, maybe just in time for the LA Olympics.
So the dream of the flying car, it feels closer than it has ever been. The technology is getting there, and the path through regulations is becoming clearer. But that leaves us with one final, and maybe most important, question. The engineering might get solved, but the biggest challenge of all could be integrating this completely new way of travel into our already complex cities. The technology is taking off for sure, but the real question is, are we ready for it?